My name is Daniel Willman. I'm from Osmocom, and I'm here now to talk to you about the open source mobile communications, in short, the Osmocom software stack that basically predates Osmocom, the company I work at. So first of all, for just an abstract about free and open source software, all the people at Osmocom, and I in particular, we come from an open source background. So basically in the early days with the internet, you had open source software, which is quite successful nowadays with operating systems like Linux also on smartphones with Android. You have closed parts for Android, but you also have lots of open source software. And I guess Android would not have been possible as is without the use and adoption of open source software. Anything web related in the early days is open source. The web basically runs on open source software. And yeah, it's a collaborative effort. You have a low cost of entry. Everyone can start. Everything that has been developed is basically put out there. And you can basically enter a given field in quite a high level and don't have to reinvent the wheel over and over again. But sustainable FOSS projects require responsible contributors. If every company just comes, takes the open source project and does something on their own, doesn't contribute back, then you don't see any progress in the open. So, yes, Osmocom, as I said, open source mobile communications. It is basically in the early days in 2008, after 2007, where OpenMoko, which a lot of the developers that ended up in Osmocom were involved in OpenMoko as well, was a first try to get an open source mobile phone, or mobile phone powered with open source software. And then in 2008, the Osmocom project basically started as a means to free the cellular mobile networks. And from the telco providers, historically, that field has been quite closed source and closed. Not much collaboration was going on there. So it started with a Siemens BS11, which is a micro BTS. And back in the day, a micro BTS weighed about 45 kilos. It had a traditional E1 link, so nothing over IP. Was connected to the computer, and the Osmocom project started with BS11 ABIS. Later it was named BSC Hack, which just tried everything to get a commercial BTS connected to an open source software stack and make calls, SMS, and much later then also data, so 2G, GPRS, and Edge as well. So we started developing one thing at a time. We took working BTS with the TRX commercially available, and then developed the BSC behind it, taking lots of shortcuts, not implementing all the traditional layers of a classic network at first. So the BSC hack was a BSC. It was basically a network in the box. It was the MSC, home location register, so HLR, VLR, SMSC, and everything else. So that's how Osmocom started, but Osmocom is home to basically lots of projects nowadays. You have libosmocore, which basically evolved out of all the code in the early days, which has, well, lots of basic handling. Most of our stuff is written in C. So lots of timer handling and other sorts of stuff, coding, decoding of GSM. Basic GSM functions with SMS alphabet encoding, decoding, and so on and so forth. But apart from the cellular networks, we also have, under the Osmocom umbrella, support for Tetra, GMR, so satellite-based phones, which is Turaya. There's DEC, there's P25, which is basically has the same goals as Tetra does in Europe and is used in the US. So basically radio for emergency services, police, military, and so forth. And yeah, there are some projects that are directly related to an SDR with visualizations, spectrum analysis, so on. And also, back to the cellular projects, we have a couple projects that deal with SIM cards. So SIMtrace is able to basically emulate a SIM or sniff traffic between a SIM and a phone, and also provide remote SIM support, so you don't need to have any sort of SIM physically present, but you can just relay the communications over the internet and have remote SIM. Yeah, nowadays there are about 60 projects under the Osmocom project pages and over 100 Git repositories. So just to give you an idea of how many things there are. And when I say that we mostly use C, that's for, well, embedded purposes, but there's also, I mean, many things start off as Python scripts, especially with the GNU Radio supporting stuff, and we also have a couple of Smalltalk projects that deal with the core network. Okay, so for the cellular infrastructure, there is on the top or first level, the lowest level, we now have Osmo TRX, which basically is the base transceiver station that supports different hardware backends in order to implement a layer 1 for GSM. Osmo BTS is the BTS implementation, so it supports the hardware that we sell or different SDR dongles, hardware like Lime SDR as well. Support for that is ongoing right now. To use that as a BTS and connect to the network itself. On top of the BTS, the base transceiver station, is the base station controller, Osmo BSC. This one supports commercial BTSs, so over E1, physical E1 link, we support the Siemens BS11, which was the first one. We support other BTSs as well from Nokia, and I have a slide on that in a bit as well. So commercial BTSs, but also IP-based commercial BTSs, which is the Nano IP, as well as our product from Osmocom, the Osmo BTS, and of course we support, together with Osmo BTS and Osmo BTS TRX, Osmo TRX, and the SDR as basically the hardware device, support SDR devices, such as the USRP series from Etis, and also the Lime Micro. On top of the BSC, or actually as a replacement for the BSC and everything that comes afterwards, we have the Osmo NITB, which is the basic network in the box, and as I mentioned, does all the mobility management, SMS calls. It does have an interface through SIP, so you can call out and interconnect as well, but it doesn't do all the roaming stuff that you would expect in a core network. Then most recently we started with the Osmo NITB, which does everything for us conveniently. And now we have seen the need to basically split out the components of the network in the box and have a separate MSC, a separate home location register, so both the MSC and the SGSN, for packet network has to authenticate or wants to authenticate against the HLR, so we have to split that out, and we're starting to go more to a more diverse approach of having the individual components available, but you could still run them on the same ARM processor, for example, and create a network in the box. It's just a distinction in the software packaging. So the MSC right now still includes SMSC and the mobility management stuff for GSM. Up until there, that was all the circuit switch side, so voice calls, SMS, and other signaling. From the Osmo SGSN is serving GPRS support node, which provides the functionality for packet-switched internet connectivity through GSM, which is GPRS and Edge. And for the SGSN, basically on the hardware side or on the lower layers, you would have the PCU, the packet control unit, which isn't displayed here. But we have that as well, and that's also working with the commercial base stations as well as the SDRs that are using Osmo BTS with Osmo TRX. So the SGSN, which connects to the PCU via GB, and then we have the GGSN, the Gateway GPRS support node that basically has the tunnel endpoint and tunnels the traffic from the mobile stations into the internet. And there's also many other special issue projects that we developed or we had to develop either to circumvent some, not circumvent, but work around some licensing issues that our customers had and some special requirements with off-site networks with high latency, low bandwidth satellite links, and so on and so forth. So this is basically the picture of how it fits together. You have the Osmo NITB on the left side, which can connect to, for example, Linux call router or via a SIP connector, the Osmo SIP connector. We can connect to basically anything that talks SIP. For calls, it has an SMPP interface to deliver SMSs. And of course, calls and SMSs within that network can be delivered without use of anything external. The NITB can either connect to a third-party BTS or Osmo BTS or a hardware running Osmo BTS, and Osmo BTS has support for the Sysmo BTS as well as with Osmo BTS TRX SDR hardware. On the other side, you have the packet switched part, where you see the Osmo PCU at the bottom, which can connect either to a third-party SGSN, so integrate with any regular core network, or run our Osmo SGSN as well as then our OpenGGSN, or as you can see, also third-party components. So everything colored blue is third-party. And yes, so the other application, as you can see, we did have Osmo BSC for quite a while. As I mentioned, there is Osmo MSC now as well, which is not shown here, and Osmo MSC as well as Osmo SGSN and Osmo GGSN don't only have support for 2G via the A interface and the GB interface, but we also support IOCS and IOPS to have support for small home node Bs for 3G UMTS devices. Yeah, this is just another overview of the hardware support. On the right side, you have that's the traditional hardware over E1, which, yeah, probably no one really wants to use anymore if they want to set up a quick small site. But the support is there, and then we also got support for the IP access nano BTS with ABIS over IP, and after we had support for that, we also supported different other. So we used the A over IP, ABIS over IP protocol that, well, once we understood it and implemented it for the Sysmo BTS range of support. So basically, for a network-in-the-box based system, you have just the diagram on the left. You have the mobile stations, which connect via RF to the BTSs. BTSs connect via ABIS to the BSC. And then you have basically a BSC connects to the MSC with the VLR, and that one connects further to the SMSC identity register, HLR, AUC, and so on, the core network. So basically, that is all that our network in the box provides all that. And the setup, the most basic setup reduces to the MS connecting to the BSC, which connects to the Osmo NIT-B. But in the even most basic setup, if you have a BTS that is powerful enough and just so the Sysmo BTS, which just has an old ARM processor, the Osmo NIT-B runs on the device itself, so it's different software, but it's a complete network in the box. So of course, target for the network in the box is not a commercial operator, but you can have island solutions like rural coverage. Someone mentioned Mexico, so Ritzomatica is a collective in Mexico that basically uses legal hacking to get airwaves in remote villages where no commercial GSM operator wants to operate a network because it's not cost effective for them. And they basically lobbied for regulation to give them the spectrum, and are now running small networking boxes with Osmocom software. And actually quite a complex setup because they're using Osmo NIT-B and the SMPP interface and the SIP connector to then again re-implement roaming on top of that. So villagers from one village can go to a different village, and not directly, but after a time, assuming all the villages actually have uplink to the center to an internet, they can do roaming. So the villager keeps his own private number in this in this big private network, and depending on which village he is, the call either gets connected locally or it gets bounced up to the uplink and into the other NIT-B installation in order to facilitate a call. And SMS works there as well. They have a prepaid model, so have done quite some work in order to make the NITB model work their way, then implementing roaming stuff back in. Of course, there's also there's marine connectivity, so having ships with GSM on board, either for crew or crew and passengers, and having a satellite backhaul. I mentioned earlier with high latency links has some issues where the network in the box approach can provide useful. So you have basically everything co-located on the ship, and don't have to deal with the delays for local calls. Then the other use case is using the radio access network to connect to an existing operator. So using basically the BTS, Osmo BTS, as well as Osmo BSC to connect to third-party operator-controlled MSC. That is quite nice because sometimes, or as far as I've heard, because of license restrictions, it's not really in the best interest to use one BSC per BTS, but of course with open source software you can just do that. And then we have a proxy again on land, which basically nets the BSC connection. So from the MSC side, it looks like it's just one BSC with many BTSs, and so you get around a couple of limitations there. And if you have the BSC directly on the ship as opposed to on the other side of the satellite link, then things just go much faster. So you have on 2G, if the phone requests a channel, the BTS relays that to the BSC, and BSC says to the BTS, okay, open a channel. So you have lots of back and forth communication that just suffers from the lag if you have a satellite link in between. And then we also have other optimizations for especially satellite links with high latency. Osmox can multiplex multiple different voice calls and also multiple voice frames of one call into one packet, because if you use AMR over RTP, over UDP, over IP, you basically have, the overhead is immense. And if you already have 500 millisecond lag, then 100 milliseconds more doesn't really matter that much, and you can have a much higher payload over these expensive links. Okay, so the right is a picture of how we started using Osmocom. That's the Siemens BS11 at the bottom of a tree, and the antennas are located not more than 2 meters high above the ground, as the license regulation stipulated back then. It was at a hacker conference in, I think that was actually the Netherlands. And those were really good proving grounds for our software when it was being developed and immature, because you had lots of different phones, lots of different situations that you couldn't really test at home. So you can basically use commercial BTSs and use them together with OpenBSC to connect to a core network, or use them with Osmo NITB to provide an island solution. You can use Osmo BTS hardware, such as LimeSDR, once the support is finished, to do basically the same things. And about Osmo-TRX, which is basically the lower layer, the physical layer for GSM. It's based on the OpenBTS code. As you might know, OpenBTS does similar things, but in a different fashion. So they just want to provide a link from the GSM air interface to SIP. And Osmocom is going a different way. We want to basically recreate all the core network components. But for the layer 1, we use the OpenBTS stuff for the SDR. And yeah, it implements the first layer, works with most ETIS USRPs, UMTRX, which is a project that started within Osmocom as well. And as I said, the support for the Lime SDR is still ongoing. It's not 100% working right now, but some integration issues. So that was cellular infrastructure. Osmocom also has, or under the Osmocom umbrella, there are also some projects that deal with other mobile communications, such as the terrestrial trunked radio network, which is used by police and emergency relief services in Germany now. And it's also used by private companies, such as power companies or others. I don't know how it is in the UK. There is an SDR implementation for Tetra for the lower layers, so for Phi and Mac. And we have receive working and TX partial. So it's an implementation of a Tetra modem. And there are Wireshark dissectors for the Tetra protocol stack. So you can, it's just basically to showcase what and what kind of stage that is. You have a couple Python scripts that use the SDR to demodulate the Tetra signal, then convert it, and then basically decode the MAC, and that will give you console output of what has been received, and also send GSM tab packets to localhost, which can be received by Wireshark, and then the Wireshark dissector can decode that and tell you what is happening there. And yeah, I mean, this project is far from being finished, so if you're interested there, they could use a lot of support. As well as Osmo GMR is Geomobile Radio, which is basically GSM for satellites. So GMR is used by Turaya, and they also implement a radio modem again, so the lower layers, and have partial Wireshark dissectors to see what is going on there, but it's not like the cellular infrastructure that you have a running program and you can basically make calls or something like that. So the GMR A5 crypto has been reverse engineered by the people working on it in order to, so if you know your key, your KC, and you then sniff the encrypted communication, then you can decrypt them again. And recently also the voice decoder for Osmo GMR was implemented. So lots of building blocks here and there for Osmo GMR, but well, still missing, if somebody wants to do that, putting pieces together, and also lots more development and research can be done in that area. Then for basic SDR, the Osmocom project also has some visualizations, spectrum analyzers, which uses GNU Radio, and GR Osmo SDR, which are GNU Radio blocks specifically for our purposes. And yeah, those are basically two screenshots, two examples of Strangelove and GR phosphor. Okay, just a couple words about Osmocom. We're founded in 2011, basically after the need arose to provide professional services for Osmocom software. It was founded by Holger and Harold, located in Berlin, and we are now 11 employees, 8 of which are doing R&D, software engineering, some hardware engineering as well. We sell services around Osmocom productization. I mean, we sell the Sysmo BTS, which basically packages all the cellular infrastructure, software inside a box, and provides a working network in the box. And the project was founded by the people that originally, or not originally, but still love doing open source software. And they started the Osmocom project way before they started Osmocom. So all our Osmocom contributions are FOSS, and I would say about 80 to 90% of everything we do is open and out there. So yeah. So as I mentioned, there were a couple of projects like the the Tetra support and the GMR, where we as in Osmocom are not involved in that so much, because there's no real customer request or desire for that. But for the cellular infrastructure, we contribute probably 80% of all changes that happen there. Yeah, Osmocom is free open source software, has no license costs, and that makes it really easy to use. But if you're a company and if you're using it, then please play by the rules. I mean, Osmocom can only survive if development that happens at Osmocom goes back into Osmocom, and if you provide patches, address the feedback and yeah, get stuff in. Yes. So these are a couple references where Osmocom software is being used in. So OnWaves is a maritime operator. Rhizomatica, I already mentioned the collective in Mexico that is doing village or deploying village BTSs, village GSM, and others. So yeah, Osmocom is free software. You can the Osmocom umbrella itself includes many things, not just cellular infrastructure. 2G mostly, we came from the 2G part, but we also have 3G support on the core side now. And yeah, use Osmocom. So this is some further reading and links for the projects, Osmocom projects. The Lime SDR page is there, which already has some info on it, how to set it up, and we'll have more info once everything's working and running. Mailing lists, we mostly use mailing lists for communication or IRC, so please go there and look at the mailing lists. We have different mailing lists for different topics, so lots of stuff is happening for the cellular mailing list, but the Tetra, GMR mailing lists, they're separate because they might not want to know about or listen to all the other talk that's been going on. And then this year we had Osmocom, the Osmocom conference, which features some tutorials about how to set up, basic setup of the network. So if you're interested in that, the lectures were recorded and the recordings are online there as well.